Hey there. Today I'm gonna try to do a little path following script so that I can make something follow a circle or a line or a shape. Was looking at a shot from Star Trek 1 and I saw some shapes moving around in a circle and a line and a curve, and I was like, can I make this in VEX? And yeah, I wanted to kind of show you one way of doing things. There's built-in ways of making followers, and there's a million ways to do anything in Houdini, but I kind of wanted to just give it a shot with just some codes and some VEX and see if I can do something decent. And yeah, so I'm gonna put a geo node down, and then I'm gonna use a circle, and I'm gonna use a primitive. No, let's go polygon, and then let's make it lie flat down on this plane, and let's give it a lot more points. Let's go 120, and oh yeah, this showed up here because I clicked on. Let me just delete it just so I show you. So I go split top to bottom, and then I go inspectors geometry just by right clicking on this box. So now I can see all the points. I'm not going to go into Super VEX basics because I tried to do a little video primer on that last time because this is just going to be pure VEX. So yeah, I'm going to try to explain things as I go along, obviously. So it's a circle and I want something to follow it, like a point. I want it to follow along all those points. Now you can use like complicated functions, which are great. I think near points is one, and XYZ distance is a different one, but I'm just gonna do it a very lazy way. I'm just gonna delete points that are not the one I want, and thus make a circle follower or a shape line follower. So I'm gonna make attribute wrangle, and I'm gonna put it down here. Now, I know all my points can be accessed if I go at numpt. So I'm just gonna make that into an integer. Point count equals numpt, just so that I'm not using all these built-in functions all the time. I am, but I want to access it without using it directly. I'm gonna make a test variable, just so I have a way of debugging. So if I go add test equals ptnum equals point number, point count, I can see what's happening. So I know there's 120 points in here, which is good. And I don't like the way the normals are here, and we're probably gonna need to use the normals in one point. So I'm gonna try to make a more circly based normal. Which we can cheat this quite well with a resample node, which reduced our points. That's fine, whatever. We can change the point count afterwards. But if I go into the tangent attribute, it's gonna make me a little tangent variable, which you can F1 and look up tangent and see a more complex explanation, but for now I'm just gonna visually show you. So the attribute mix called tangent u, I'm gonna rename that to n, which will override the normals, and you'll see that these points now actually follow the curve, which is quite cool because now I can kind of use these as like velocities or scale multipliers or a lot of things because they're actually out of direction. I don't need this flow at all, so I'm gonna go back to the circle and make it open. And I'm gonna go in here and delete the lines, so I've only got a bunch of points. All right, cool. So now I've got my points. I've got the point count, which now went down 64. And yeah, a very basic approach of just making something follow the circle is just gonna be I don't know the number of points, so I'm gonna say float percent equals, let's make it 0.2% out of point count. And then if it's not the percent I need, I'm gonna say if, first of all, I'm gonna make this into an integer because I'm using points here, which I need to because it's gonna divide by, you know, point of a number. But I'm gonna say if percent equals at ptnum to this, whatever this is, else to something else. And I'm gonna cast that into an integer because point number is an integer. It's like 1, 2, 3, 4, 5, whereas the percent could be, well, I can show you. So if I make this test variable the percent, oh, double equals, sorry. You'll see what this looks like. It's not pretty. It's got all these 0.000s. Also, like, that should be a bigger number. What am I saying here? I'm saying give me 0.2, oh, 0.2 times pt count. There we go. So it should give me, yeah, 12, which is 0.2 of 64, you know, 0.4. Okay, so it gives me different numbers. But this has this little thing in the end. So if I use int percent, I can actually show you here. So if I go int percent, it's going to give me a flat number with nothing at the end. It's going to round it up or down depending on the number. So now that I've got that as an integer, I don't actually need to show you any more of this. So if this is an integer, don't do anything, but otherwise remove the point. Remove. So now I've just killed every single point apart from one, which is this one. And if I want to, for example, animate this, I can make this into a temporary variable. Just so I make it clear that I should not be using this like this, but if I make it temporary, there we go. Now it animates. So that was a very quick way of just making something follow a curve. Like you can take this and then throw a pig on it, copy the points. That's the pig, that's the thing. Okay, and get rid of all my indicators. No. That's the geometry copy. Why is it not? Let me pack it. Oh, right, I haven't actually done anything. So there we go. Now it actually animates. And you'll see that it actually rotates as well. Now, the reason why it rotates is because I just changed the normal in the resample. So if I take this resample off, it's going to stay like this. But because I put the resample in, and I changed this tangent to n, now it's got an actual direction it can go to. Now I want to thank CG Wiki, because CG Wiki actually put like an article on the tangent attribute manipulation. So they're the ones that came up with this idea. So thanks, Matt. Okay, so in here, oh yeah, I don't need any of this anymore. So I'm just gonna leave that where I was. Go back to my points. Okay, so it moves. But if it goes above 1, then it's effed, because it doesn't, because the point count is clear, like a clear number. Now I'm going way above 1, so it's delaying everything now. So I'm gonna change some stuff. So I'm gonna use this percent sign instead. Let's see, how can I best use this? Let's see, how can I best? Actually, no, scrap that. Firstly, I should say how long I actually want this to take. So like, let's say I want this to take, let's call it time it takes. Let's make it 20 frames. And I want it to loop over that. So I'm going to say float looped frame equals add frame over time it takes. Cool. And now I'm gonna say percent, let's delete this stuff, equals loop frame over time it takes. I'm just gonna copy paste this. Multiplied by the point count. Okay. I'm just why am I getting 2 points? All right. Okay. Now, why is it looping? It's because I'm saying here, I want the frame to be frame, which is, obvious. Over time it takes. So if it's frame 1 over 20, that's, 1 over 20. Progress is this. But like if it's like, I don't know, frame 70 over 20, what this takes is the last bit, 0.5. When you use the sign, you know what? I think you should just go into the MD and docs, because I am not the mathematician and I know this works, but if you want a better explanation, let's see. The remainder operator returns the remainder left over when one operand is divided by the second operand. So 13 over 5 is 3, and 3. So this is like a low utility thing for a lot of people, is they will use this as a way to just keep it looping over a specific amount of frames, which in this case it works. Also, it's going to give you a little issue with numpt because it's an array that starts at 0. So I'm just going to do a -1 here to make it even more perfect. So it's actually, you don't notice it because there's not many points, but you will notice it later if I don't adjust my point count a tiny bit, just for 1 frame because of the fact that the array starts at 0 and goes in 63. Yeah, okay, cool. So now I got a thing moving over 20 frames. So I'm gonna make more adjustments. I'm gonna add an offset. So if I want to like have a 20 plus something, I'm gonna say float offset equals channel float offset. And I'm gonna say actually no, let's make it times time it takes. So that's actually an offset based off the total time. And then I'm going to combine these two. So I'm going to say plus frame plus offset. I'm going to delete the stuff that I've been messing with and only add the offset. So now I've got a percent based offset. So it also starts at a different percent. So if I was to make like 2 of these, I could like manipulate this so that some of them start here, some of them start there. Like I could, like if I make a second one of these and I make the start here and then I merge them. Now I got 2 moving at different offsets. So that's useful. All right. So this was I think, no, I want to put some easing into this because like this just moves linearly now, which it's not as fun. So I'm going to use a ramp. So instead of saying percent is this, I'm going to put a CH ramp. So CH channel ramp, and I'm going to call it percent eased. Comma, this combo here, loop frame divided by time it takes. And I'm going to click on the little, this little plus thing. Now, you don't see any difference because it's default, but now, like, I could theoretically slow down and then speed it up and then slow down and speed it up. I can really, like I was noticing on the image that at the edges, it's a dot, but in the middle, it's a curve. Like it actually shears a little bit. So like I could theoretically use this to more fine-tune my animations. And I'm going to open this up properly. And I'm going to change this to be a curve. So I'm going to use, let's go Bezier. No, let's try something else. Let's make a B-spline. Maybe it's not changing because I need to change all of them. So I'm going to right click and make it Bezier. There we go. Oops. A nice Bezier curve. So I'm going to make it more curved up. There you go. Cool. So now I got a little bit of ease happening here. All right, so I'm gonna say this is like the basic version. Now I'm gonna start making this more utilitarian for more complex things. So like, for example, if I want to have a bunch of points, not just one. So first of all, before I just use P, so let's instead just, organize it there. Let's make a vector point position, and I'll put another one for the normal vector normal. And over here, where I didn't have anything before, I'm gonna say vector new position equals. Now I could use P to declare this because I'm already there. Same with the normal, like say vector. This is new. Let's go a new normal equals normal. Just make sure that, yeah, okay. So I could do this. So now I got like a way to keep track of what's happening. Let me just make sure that using initialize variable normal. Let's call it point normal so I can not use defaults. Oh, what am I doing? What am I doing? Vector new normal position equals this vector. There we go. So I'm making a temporary one here for both of them, and then I'm gonna say, you might think this is redundant, but this is gonna be more useful the more we have points. But I'm gonna say the variable that we made at the top, let's reference this from there. Sorry, pass along this variable there. Okay, cool. So now that I've got these two, I am passing these variables down there. And then at the very end, I'm gonna actually put this attached to the object. So I'm gonna say v at point position equals point position. And v at normal is the normal. All right, now we've passed along the data. So now I have the normal and the point position in its own different variable, which is great. So I'm gonna not use P because I want to make this into a detail wrangle instead of a point wrangle, but which would be more useful for making a one-off declaration. So instead of using P, just in general, we could also use point. So we can use the point function, which fetches point information. Just like if you were to use detail or primitive or whatever, you can get that specific thing's information. So I'm going to 0, which means the very first line that's connected, point at 0 at P at ptnum, which will do the exact same thing as what we did before. The P and N are just shortcuts. So same thing with the normal. I'm going to just say N at ptnum. So now we got it this way, which is great. Cool. So that's the only difference we made in this file, which is great. So in here, I'm going to start messing with this seriously. So I'm going to actually make this into a detail wrangle instead of a point wrangle, which should break it. All right, cool, it broke it. Because you're not in a point mode anymore, so it doesn't know what ptnum is. So instead of doing this, you're going to have to loop through the whole object once and thus simulate a point wrangle. So I'm going to say for int I is 0, I is smaller than the length of, I think it's numpty, which is the, oh, right, I've already got it here. Although I modified it, so shit. So at length and numpty brackets I++, which should loop through every single point. And then in here, I'm gonna close this down there. So now this should run it for as many points as we have there. So I don't have ptnum anymore. So I don't actually, let's see. 8%, instead of using ptnum, I'm gonna use I, because this is gonna be acting like a ptnum. So I. Let's see. What's your issue? I don't actually need length because it's already not pt. Cool. So what we did here is we recreated a point wrangle right in here, and it's not. I mean, I guess it's not like, you know, the most perfect utilization of CPU, but this only runs once, unlike the other one which runs 64 times. So really, it's not much different. So in here, I can access the ptnum using I, and I'm using the points function to do what p and n did. So now I can use this as a more general function. Let's see. So I know what the number is for points. I know what the number is for normals. Let's do some more organization. So yeah, 0i. Cool. I'm just taking a look at my code just to make sure it's nothing's messing up. All right, how can I best do this? Well, first of all, let's just try to split this as much as we can. So I'm gonna make a different wrangle. Let's see. Assign position. Leave 1 point. Maybe in this one we can delete stuff, and then in different one we can animate that 1 point. Yeah, that could work. Yeah, this doesn't actually do anything. I'm just trying to figure out to split my color in a neater way. Let's see. Well, what I want to do is make a bunch of points at different positions, and they're all randomized and they're all moving around. So I'm gonna make a brand new attribute wrangle. And make it a detail because we only want this to run once. I'm gonna put detail mode on. And I'm gonna make a float code, float randomized. Percents. And here I'm not sure, S or Z. I'm gonna say I at point count equals channel I brackets point count. And cool. So that should give me that point count. And which basically is I want to have it so that I can declare how many points I want in total. So I'm gonna call it let's say I want 11 points in total. For int I equals 0. I smaller than point count. I plus plus, run this 11 times. Push into this array we've just made. I'm gonna prevent myself from making more errors. Push randomize percent I. And then make an actual variable here. So f open bracket close bracket at randomized percents equals randomized percents. Cool. Now this is neither a percent nor is a random. I just wanted to have something to declare in the first place. So I could use the random function. Oops. which then I can put I in there, which will make me 10 random numbers based off a seed. So if I press F1 while hovering over random, you can see the random function, which takes seeds and takes a bunch of stuff. There's several random functions. There's all these, like there's random hash, random Worley. Yeah, there's a lot of, like, I think the one I normally use, I think, is random underscore BRJ, which I'm gonna put like 1 here, which is just, there's a bunch of really nice ones there, because there's nothing really truly random. It's just how spaced out do you want it to be. So with this one, there's less clumps in the numbers, so this has better distribution. Ultimately, it doesn't really matter, and I'm just nitpicky. So I've got all these random numbers. So these are like the random start points, you know, the random like positions where things will start. So I'm gonna say create random points, or should it be positions? I'm not sure. Yeah, let's just put that here instead. Cool. So let's grab this. So I'm already in detail mode, so I don't need to worry too much about stuff. So I'm gonna go float randomized. Do I still have it in my cache? No, because I'm very paranoid, I'm gonna actually directly copy paste it. Randomized percent, which is an array, equals F. And yes, it's confusing because one array is like in the end, but if you're using the built-in variables, it goes before the @ sign. I know it's like not the most intuitive. So now I've got the array linked. So it's going through all the numbers here. So I'm gonna put an even bigger loop in here. So I'm gonna go for I. I'm already using I, so let's go with y, because why not? Int y equals 0. Y is smaller than length of randomized percents. So like loop through the count of like of how many numbers there's in the array. So this should go 11 times. Y plus plus. Cool. So that's gonna do 11 times, hopefully. All right, no error. We've just made this 11 times slower, which is great. Still pretty fast though. So, okay. So we've just put all this stuff here. And this is doing the exact same thing again. So let's modify some things. So instead of making this position into just one vector, let's make it an array. Same with the normal. So instead of having over there, like I am grabbing the new position. So instead of doing this, I can say, because arrays are a little bit different, so I can go push point position comma new position, which will push the new position into the array at the end. Same with normal. So if I can go, yeah, push point normal array new normal. So that pushes into the array. I don't need this anymore. And so, yeah, so now I've got an array, which I'm filling out here. It's all getting nice and full. And then at the end, I should probably output the stuff. So it's already outputting the vectors. So I'm just going to modify that. So I'm going to say v at point position, let's make it s, because there's multiples of them. And there we go. Here's an array of positions, an array of normals, which is nice. I can't spell normals. Cool. All right. So now that we've made a bunch of points, we've assigned them, and then we've animated them, and then we've given them an output. Now you're not going to see much of this because like this is just declaration status at this point. I'm just gonna like take out the stuff with the removing of points here. Just so I have something that's not in this array, in this attribute wrangle. trying to keep it clean as much as I can. All right, so I've left the circle alone. And then over here, I'm going to delete the point just so I have something split up. So I'm going to say if ptnum is bigger than 0, remove point 0, comma ptnum. So I can only like this way. I've only left a single point just so I have something still down here. Otherwise, it's not even going to do anything. And so here, I'm going to make this into a detail. So it only runs once. Now I've got all this access to every single point. And I've got access to the normals. So yeah, let's grab the stuff again. So I'm going to grab this. Actually, no, I'm going to grab this over here. At the end, the positions of the normals. So over here, I'm going to say, we're going to grab these IDs here. I'm going to say vector point positions equals point positions v comma, yeah, what, you know, that thing. And I'm going to say normals. There's that. So now I can access these. All right, I can access these variables. I'm going to say int count equals the length of point positions. So I want to get all the, like, how many points we've just made. So I'm going to get the length of this array. So length of point positions. And I'm going to say for int I0, I is smaller than count, I++. All right, now we're in a single array. Let's make a new point. Int new point, because we're making a brand new point, may as well just have a point of reference, equals add point, which is a built-in variable that adds a point. 0, because, you know, we're coming in from here, so we're gonna keep going with the 0. Comma I, which will make me a point. This should actually show, yeah, there we go. It already came up with 11 points, plus the one we had before. So I've just made a new point, and vector normal, like singular, is normals. So I have the current normal that I'm gonna apply to this point. And I should get the P, the position, shouldn't I? Let's see. Yeah, I should probably get the position as well. So vector position equals point position I. All right, now I've got access to both of these things. Let's assign these things to the point. So it's called set point attribute 0 comma p comma I position comma set. But we've still got a single point that exists in this chain down here. So I gotta remove it before I do anything like that. Remove point. Which we were just using it for like a way to keep the chain going. I'm gonna say, because we had a point that would probably have made a point number, I'm gonna say I+1, just so that we don't mess with the point number that Houdini might have given it. So I'm gonna say make the position and the normal, pose and the normal from the array we had. Okay, that's animating a single point. This is where I'm gonna start messing up because of my use of I and I+1. Okay, what if we don't use I+1? No difference. Let's see. Yeah, I don't need PC num, do I? It's sub detail. It should be 0. Oh, there we go. Okay. All right. It's animating a single point. It should probably be animating all the points. Why do they all have the same number? Let's check here and see the positions. Oh, they all have the same number. Yeah, they all got the exact same number. Well, let's go back to where we assigned the point position. Let's see. What am I doing here? I am assigning the position. Push the new position to the point position, and point position is Let's take a look. What am I doing wrong? Well, let me just highlight this for a second. -9. They should not all be the same number because the randomized variables are a different number. Okay. I think it's because I've been working outside the loop. So if I select all these percentages, because this percent is static, it doesn't exist in the loop. So if I put this percent in here, delete this test variable. If I put this in the actual loop and stop using the manual channel for the offset and actually use the percent I created. So instead of using the offset, I can use random percents y. Yeah, all right, that made different positions. Okay, that makes more sense. I'm still gonna use the easing because I like the easing, but like, yeah, I should, yeah, this is in a loop, so every percent's gonna be different because I've made it different before. And see if that makes, there we go. All right, well, that made different spacing for all of them. And that's pretty neat. Let's see. What else could I do? I can do a lot of things with this. I mean, even right now, I could make a circle. Not a circle, a sphere. And then pack that sphere. And then copy the points. Which, let's make it smaller. Which starts making some spheres. I can randomize the Y position. I can randomize the size of it. We have the access to the normals, so we could use that scale. Let's see. So for example, we have, I can make a new wrangle here. And let's call this like add scale. By default, the variable to declare scale when you're using copy points is p scale or scale. So I can use scale, like for example, if I do scale equals 2, now they're double as big, 2.5. But it's also vector, so I can modify individual ones. So I can say vector scale equals 1, set 1, and then I say scale point z multiplied equals like 0.3 or something. And then I've got these disks here. Now I've got normals to use as like reference. I could also put a velocity down, point velocity, and then I can put that here, which will make me a point velocity like like a float variable. Think my numbers. There we go. Okay, it's a float, like a vector. So I'm gonna use that to add some scale change. So I can say like vector equals add b, and then velocity.x or something. Let's see that make a difference. There we go. So now that started to modify some things. Let's fit that within a range. Fit 0, 1. Velocity.x 1, 2. All right, that just limited how much maximum you can stretch and skew things. Yeah, so you can use velocity to do a lot more animation. And yeah, I'm gonna say that's it for now, because you're gonna I can keep going with this for like an hour or two and add so many more customizabilities. And I'm gonna put a more advanced file in here in the comments, and you can mess with that one. That's got a lot more options. So in this file, I've done exactly what I've done here, except I've added more sliders, I've added a control node so that in the control node you can just set your point count. So let me hide this. If I do this, there we go. So this one has a point count changer, so you can change the control here of how many you need. And I added like an ease ramp here, which links the other one, so everything can be more like a uniform place. I also changed it so that they have different Y spacing and width spacing, so you can change how wide it is at the bottom, how wide it is at the top. And yeah, like this is just another hour or two of messing around. Yeah, sorry for the very over-the-top way of doing something like this. It's half usability and half learning some VEX, so hopefully anyone out there found this useful. Thanks for your time.